Okay, this is section 1.4. We're going to do the equations of lines. And the book talks about the point slope form of lines, but I'm not really a big fan of the point slope form, so I'm going to show you another way to do this using the point intercept, slope intercept form we already know. So if they give you 2 points, you can easily find the slope, right? That's what they did here. In this part of the equation, they uh, they found the slope right here with the 2x points. And then they redid this equation so that they put this y minus y1 on one side and the m. This is the point slope form. Okay, so we're not going to pay too much attention to that. Okay, what we are going to pay attention to is the using the slope-intercept form to solve these problems. And you can see that right here that they actually want you to find the slope-intercept form anyway, the line passing through those 2 points shown. So there's no reason to memorize another formula when we already have one we're using. Okay, so we're not going to use the point slope form on this equation, but we are going to find the slope, right? So the slope is easy to find. You just take the difference between the y numbers. That's here, right here, that's the y numbers, right? And these are the x numbers, the difference between the x numbers, the y and the x, the rise over the run. And we're not going to bother with this part of the equation. So, but we do get the slope here. The slope is 2. Okay, so we can use the slope-intercept form. Now we have the slope, and we have one. We can use either one of these points, these 1, 7 or the 3, 3, to figure out where the intercept is going to go. So we already know the slope. Now we just need to find the intercept. Okay, so we're going to do that. You know, the slope-intercept form is y equals mx plus b. That's the symbolic form. We already know there's 4 symbols here. We already know 3 of them. We know what m is, -2, and we know what an x and a y that work. So I'm going to put the x and the y that work here. So on the first one, 1, 7, remember the 7 is the y number, so I'm going to put a 7 here, equals, the slope is -2, so I'm going to put a -2 there, and the x is 1, and we're trying to find out what b is. Okay, so it becomes an easy problem to figure out what b is. We get 7 equals -2 plus b, so b equals 9. We put that back into the slope-intercept form of it. We get y equals, now we're going to put, we know the slope is 2, so we're going to put 2x plus 9. Okay, and that looks like it's going to go through 9 up here. If we look at this graph, it does look like we keep going, it probably will go through 9. So that seems like a reasonable answer. Okay, so they did the same thing here. I'm not going to, well, I guess I can erase it for you if you want to see all this. Maybe I can erase it. No, it's not erasing. Oh well. Go on to the next slide. Okay, using the point slope form, found these points here. Okay, um, using the point slope, the total list of points found on the line, write the equation of the line. Okay, so what we really need is to find the slope. So we can do the slope for any 2 points on here. They used those 2 points. You could have used the points, just 2 points right together. If we used 2, 3 and 3, 5, the first 2 points there, it would have looked like this. Okay, so we take the difference between the y numbers, 5 minus 3, difference between the x numbers, 3 minus 2 equals 2 over 1, which equals 2. So it doesn't matter which points you use. You can find the slope any way you want. So after we find the slope, then we can do what we just did before, right? We use the y equals mx plus b form of it, the y equals mx plus b. We know a x and a y that work there. There's like several of them here, so I'm going to do the first one. Just the first point is 3 equals 2 times, we know the slope is 2, so I'm going to put, the slope is 2, we know the point is also, the x point is also 2 plus b, so that leads to 3 equals 4 plus b, so that means that b must equal -1. So my y slope intercept form of the equation is going to be y equals 2x minus 1. Okay, so they need to go through a little more difficult thing to do, but then they come up with the same thing. Okay, I need to erase all that. Okay. Okay, so this is called the ax plus yb equals c. This is called the standard form of the equation. They want you to graph this equation. Okay, so the good thing about graphing this equation is that it's easy to find the intercepts. Okay, so we can take if we make the x equals 0, that means we get 2y equals that. So we know we can figure out one point that works here with x is 0 and y, so 2 times y equals 6, so that means y must equal 3. So that's one point that works. If we do the same thing with make this y 0, make the y 0, so this goes away. Then you get 3x, 3 times x equals 6. So I know that the y number is 0. So the x number must be 3 times what equals 6? Well, 2. Okay. So this is my y-intercept. And this is my x-intercept. Sorry, I didn't write it. That writing didn't come out too well there, but that's the x-intercept and the y-intercept. Okay, so it's a little more clear on that one. So the x-intercept, y-intercept. So if we have those two intercepts, we can just plot those 2 points, one on the x-axis, one on the y-axis, and draw a line. Okay, so we just plot them like that. Easy to graph an equation when it's like this. Okay, so that's the beauty of the standard form. It's easy to graph the line. The calculator solution, though, you have to solve for y. The calculator doesn't really recognize it. You have to put it in the slope-intercept form. So we try to get y by itself. So we subtract 3x from both sides. That's what they did here. Subtract 3x from both sides. Then divide everything by 2, and you get y equals -1.5 plus 3. Graph that. It looks like this. Okay, so if you want to graph it on the calculator, you have to get into the slope-intercept form. If you want to graph it by hand, you just need to find the intercepts. Okay, so now we're going to talk about parallel lines and how you do that. This is a typical problem. You find the equation of a line that passes through a certain point and is parallel to the line with the equation right here. So this is the standard form of the equation, right? This is the 2x plus 5y equals 4. But that's not really that great a form to have the equation in, especially when you have to graph it on the calculator. We need to get this into the slope-intercept form, the y equals mx plus b. So they did that down here for us. So they subtracted 5, so they subtracted 2x, then they divided everything by 5. Okay, so they got y equals -2/5 x plus 4/5. Okay, so what did that give us? That gave us the slope is what we want to do. We want to figure out a line with this same slope, the same 2/5 slope, -2/5 slope, that goes through this point. Okay, so how do we do that? Now we solve for terms of x, so that the slope is -2/5. So remember, we want the same slope. We want it to go through the point 3.5 now. Okay, so we want to find the equation that goes through 3.5. We know it has the slope of that. So we're going to use our y equals mx plus b. Okay, so we know that this is the 3 is the x, the 5 is the y. So I'm going to write that out, what I know. 5 equals, so I know the slope is -2/5. I know the x is 3, and I'm trying to find b. Okay, so that leads me to, if I multiply this out, 5 equals -6/5 plus b, and if I make this 5, I change 5 into fifths, I get this is to be 25/5, right? That's the same as 5. I did that so I can add these fractions together. When I add -6/5 to 25/5, I get b equals 31/5. Then in pre-calculus, unless the fraction reduces, unless an improper fraction like this is perfectly fine. So my equation becomes y equals, it has the same slope as it did as the other line, 2/5 x, and then it has a different intercept plus 31/5. So that's the line we're going to graph in the calculator. So same slope, different intercepts. It'll look like that. And that's the equation of the line. Okay, so we're using the same technique over and over again to figure out these problems. Okay, now perpendicular lines. Remember the slopes of perpendicular lines have a product of -1. Okay, so that means that if we know the slope of one of them, let's say this one is, we know the slope from the previous example is -2/5, we flip that fraction and change the sign to get the perpendicular slope. So if we flip that fraction, we get 5/2, we change the sign, make it positive. So the slope of the perpendicular line is 5/2. So we want to find the line, the equation of a line that has this slope, 5/2, and goes through this point, 3/5. Okay, so it's just like we've been doing before. Okay, so it's the y equals mx plus b. We know the y is 5. We know the m is 5/2. It's the negative reciprocal of this 2/5, -2/5. We know the x is 3, and we're trying to find the y-intercept. Okay, so that leads to our problem here. We get 5. Well, I'll make this. I'll make it. Yeah, I'll make it 5 would be 10/2 equals 15/2, right? When I multiply the 3 times 5 plus b. So b, if I subtract 10 minus 15, I get -5/2 equals b. So my equation becomes then, for the parallel one, I mean the perpendicular one, is that y equals 5/2 x plus -5/2. Okay, and so the graph it on your calculator, you get this look to it. And if they turn those fractions into, I got +5/2. What did I do wrong here? No, I think they're wrong. Yeah, because you can clearly see that the intercept is down here. So that they made a little the slide has a little mistake in it, so that should be a negative. Yeah, you can see the intercept is obviously down here. So I was right, they were wrong. Okay, so that's the end of the lesson for today. So pretty short. So answer the questions on the slide below, and I'll see you in class tomorrow.